Hi everyone and welcome back to Dev Portal, your go-to channel for mastering tech concept. As we all know that RCB has finally done it. They have won the IPL 2025. You might be wondering that why I am talking about this. The idea behind today's video is to talk about that how we can handle bulk updates in the system. Let's say this news RCB team has posted on the Instagram and boom, and millions of fans will rush to those posts on the Instagram. Now we can expect such a post can easily get viral and it can easily get 1 lakh likes within a minute. Now imagine you are the engineer behind Instagram system. Then how you will handle this much of traffic without crashing your database? So this video is all about that. Let's say the post got 1 lakh likes within a minute. That means around 1667 likes per second if I am not wrong. So in that case, let's say if we are triggering synchronized database writes in our system, in that case what will happen to the DB? One, that it can get slowed down. Second, it can simply crash our database. So how companies like Instagram, LinkedIn, YouTube handle such scenarios? We are going to talk about that today. So first let me go to my GitHub repo. So here as you can see I have created the architecture diagram. So this we are going to achieve today in this video. Instead of writing every like into the database immediately, what we are going to do, we are going to use Redis to collect those likes in the server, and then for every 30 seconds what we are going to do, we will flush those likes into the database in the form of bulk updates. So as you can see or you can understand what we are going to do, that whenever we get a like on a post, that count we will increase in the Redis rather than on the database, and then for every 30 seconds our batch will get execute, or you can say it will get run, and then we will fetch the records which are present in the Redis server, and those likes count we will update in the database. This is the basic flow of this architecture. So here you can think Redis as a temporary container where every time whenever any person or user will hit the like button, we will add +1 in our Redis counter rather than on the DB. So we are not doing any database operation yet. So let's say after 30 seconds we found for, let's say, post 123 we got 35,000 likes. So in that case we will do only one update rather than doing 35,000 updates in the system. So that's how we can do the activity with the help of one SQL query rather than doing 35,000 transactions. So now let's see that how we can build this simple system using Spring Boot, Redis and PostgreSQL. I have already created the basic structure of the system to save the time, and we are going to write the code for our approach. Let me walk through it. So here as you can see the project structure, we have the controller, that is post controller, where we will handle our incoming request, that is the like, and we have one entity, that is the post. This is our table that is present in the database. We are using PostgreSQL here. In your case you can use MySQL as well or MongoDB as well or any other database as well. Then we have repository to update the like count in the database, and then we have service where we will store the likes in the Redis server rather than on the DB. That is the transaction that we are not doing it here. And then we have a scheduler where we will do our aggregation on the likes, and then we will update that particular count in the database rather than doing in the service. So this is the basic flow. Now let's go to the STS and let's write the code for this. So before that writing the code, let me show you the endpoint how it looks. So we are going to create the post API. As you can see it here, post, then post ID, so that I can know that for which post this like is coming. And then if you want to hit this URL or API, you can use your curl command or you can use postman or yark as well. And if I talk about Redis, so this is how the data will look inside the Redis, that we are going to store post colon like colon that post ID. Why post colon like? So that I know for post I am talking about likes, and for the like I am talking about 101 post ID where 15 likes are present in the Redis server, and for post 102 8 likes are present in the Redis server. So this is the basic idea, and once we will update this count in the database, we will flush all the data which is present related to the likes from our Redis server, so that redundant data will not come into the play. So this is the basic idea. Let me show you the data as well first. So if I go to the PostgreSQL, this is the post table that I have created. Very simple table. ID is this ID column, or you can say the primary key, so that I can know for which particular post you are talking about. Currently only one data is present because we are going to see that how we can do the bulk updates, not doing the rather than bulk updates, how we can improve the efficiency of our system and how we can utilize the system in a better way. So we have the title, that is RCB won the IPL 2025, and then the like count and the created timestamp. So this like count, I am interested that how we can achieve this like count. We can update this like counts rather than doing synchronous update, how we can utilize our resources to do the likes in a aggregate manner so that our system will not go down and we can provide the better response time to the user with the user experience as well. So let's see that how we can achieve all these things with the help of our Java code and Spring Boot. So basic structure already I have created, as I told you. So I am going to write the logic that we are interested. So I will start with the repository. I will go backward. First I will write for the repo, then I will go to the service, and then I will go to the controller, and finally I will write the code for the aggregation of the like. So this is the flow that I am going to follow in the coding. So first let me add the repository here, add repository annotation, so that my Spring Boot know that for this interface I am going to talk with the database. So let me add repository. So here what I'm going to do, I will going to extend the JPA repository so that I no need to write the queries, because I'm only going to do the update in the system. So for that I will just write extends, and after that I will mention JPA repository, and here as you know I need to mention the entity name and with the ID column data type. So my entity is post and the ID column is long data type. Let me show you that post as well. First let me import this, and if I open this entity, so you can see it here, we have ID, title, like count, and updated timestamp or created timestamp. I didn't add it here because I am not interested to update that value for now, updated timestamp or created timestamp. I just want to update the like count. So let me close this. So this is my repository which I have created. Now let me go to the service. So in service, what I am going to do, I will use my Redis template and I will store the count inside the Redis server. So first let me auto wire that Redis template here. So I will write @auto wired, and I will write private Redis template, and let me give this a name. Suppose first it will expect key as a string argument or string data type, and value will also be string, and let me give this a name Redis template. So that's it. Now I will create one method here. So I will write public void, and let's say I want to increase the count of the like for the particular post. So for that I will create a method, let's say record likes, or rather than likes let me write like, and this will expect one argument, that is integer, that will be the post ID, and this post ID I am going to save in the Redis. If I go to the GitHub again, so here as you can see I am going to save key as a post colon like colon post ID. So same thing we will implement here as well. So I will write string key equal to post colon like colon, and then I will add post ID. So this will be my key, and now what I'm going to do, I will write Redis template dot, and now I'm going to use the ops operation. So I will write ops for value, and here I will use increment, and for the increment what it will do, it will increase the value every time whenever this method will get called, and here I need to provide the key that will be my post colon like colon post ID. So this is how we are going to achieve the how we are going to use the Redis server for increasing the value. As Redis is very quick, so it is not going to impact us. So every time whenever anybody hit on the like button, what it will do, it will increase the like count by 1. And now let's go to the controller. Before that let me add service annotation here as well, so that Spring know this is the business logic that we have put it here. So inside my post controller, what I'm going to do, first let me add REST template, not REST template, REST controller annotation, so that my Spring know this is the controller of where the entry point will be present of my application. And here I will use request mapping as well, and here I will define posts. So let me add hyphen slash as well, not hyphen. And now let me create, or rather than first creating, let me auto wire this service class here. So I will write auto wired, and I will write private and let me mention here like service, and let me write service. And now what I'm going to do, I will create one post API. So how does my post URL will look? So it will look like this. Post already I have included in my request mapping. After that I need to mention post ID and like. So this thing we are going to write it here. So I will write public and I will return string as a response for now, and then I will mention, for let's say I want to give this method a name like post, and it will take one path variable here. So I will write @path variable, and that will be of integer value, and I will mention post ID. And let me add the annotation as well. So I will write @post mapping. I will use post mapping here, and the value will be in double quotes. I will provide slash, that will be my post ID first. So I will use curly bracket as well, and then I will mention slash like. So that's it. And one more thing, because I am returning a string response, and by default response body is expecting application JSON, so I need to mention what response I want to return it here as well. So response, so I will write produce, so it is going to produce application slash text, because string will be act as a text, so that it is going to produce, and that I will return it here as well, that recorded, or rather than recorded, let me write liked successfully. So that's it. This response I will return, and before that I need to call my service. So I will write service dot and I will call record like, and here I will pass post ID. So that's it. Now whenever anybody hits this API, what going to happen, I will call my service, and from my service I will record, or I will update my, or you can say I will increase the count of the like in the Redis server. And then what I'm going to do now, I will use my like aggregate. What it will do, here I will create a method that will run every 30 seconds. So what does it means? Let's say within 30 seconds you got 15 likes, so that record is present inside the Redis, and then I will fetch that record how many keys are present for that post colon like in the Redis server. I will fetch those keys, and then I will execute a for loop. I will run a for loop, and for each individual key I will fetch the like count, and that count I will update in the system, that is database. So let's write the code for that. So first let me add the annotation. So I will write @component, and what I'm going to do it here, first let me autowire Redis template here. So let me go to the service and let me copy this and let me paste it here. So one is Redis that we are going to use, second is repository, that is post repository we are going to use to update the count of the like. So let me write autowired, and here I will write private again, and this time I will write post repository, that will be my repo. So now let me create the method as well. So I will write public void, return type will be void, and let me give this a name. So let's say I want to give this a name, because we are doing aggregation here. So what, not aggregation, actually already that aggregated count is present in the Redis server, just we are going to update that count. So I will write aggregate like, and this will not expect any argument. And now what I'm going to do, first I will fetch what all keys are present in the Redis. So for that it will return me the set of string, so that will be my keys, and I will use Redis template here, and I will write just keys. And now I need to provide the pattern. So what will be the pattern? So if you see it here, what pattern I am using, that is post colon like colon, and after that it will be a post ID. So prefix will be post colon like colon. So this thing I am going to use it here as well in my code. So I will write in double quotes post colon like colon. After that anything which is present, it will return me in the form of set of string, and let me import set here. So it will come from java.util. And now what I will check first, that if it is null, let's say keys are not present in the Redis server, so in that case I can simply return it from this method. and if the data is present, in that case I know I need to perform some operations. So for that I will write for loop so that I can take individual keys. So it will be a string of key that is coming from keys, and now what I am going to do, I already have the key. Now this key I will use to fetch the count that is present in the Redis server. So first let me extract the post ID, because I am going to update the like count for the particular post. So it will be of long data type, so it will be post ID equal to, and this post ID will come from the key itself, because if you see it here I mentioned 101, that is the post ID. So this thing we will extract from this string. So I will write long dot value of, and it is expecting one string argument, and that string argument will come from key, and here I will use split method and I will split the data using colon. Now if you observe, my post ID is present. If I split this data, this string, how it will going to create the array. It first at 0 index post will be present. It will create an array of string. So at 0 index post will be present, then at index 1 like will be present, and then at index 2 101, that is the post ID, will be present. So here I need to extract the second index value, and this value will be my post ID, and from this post ID, not from this post ID, this post ID I am going to use in my repo to update the count. Second thing what we need to extract is that count of the likes. So for that it will be string count str, or we can mention like count str, because it is a string data type, and this data will come from Redis server again. So I will write Redis template dot, and now I will use ops for value, and here I will mention get, and here I need to provide the key. So that will be the key that I already extracted, or you can say I'm already executing, I'm iterating from the keys of set. So it will be that count I got, but that is a count in the form of string. This count I need to convert it into the long data type. So for that what I'm going to do, I will write long count, and this count I will check this like count should not be equal to null. If it is not null, in that case what I can do, I can call long dot value of same, and here I can provide like count string, and if it is null, in that case I can just simply return 0 to my count. So that's it. And now what I'm going to do, first I will check this count should be greater than 0. If it is greater than 0, in that case only I know I have to update the like count. So I will write one if block here, count should be greater than 0, and now what I will do, I will call my repository. So I will write repo dot find by ID. So I will use my ID here, that is the post ID, and it will return me the optional object. So I will check if present. So what does it means, that if data is present, so in that case I am going to do some operation here. So I will write post dot set like count. So this like count we are interested to update. So before updating the like count, first I know that what is the current count. So for that I will write post dot get like count, and then I will mention plus, and then I will update the count plus by count, that is the existing count which is present in my Redis, and then again I will call repo dot save, and I will pass this post. That's it. And after that, because we have updated the count, we need to delete the value from the Redis. So for that I will call Redis template again, Redis template dot delete, and here I will provide my key so that it can delete the record. So that's it. This is how we are going to do we are overcome from the bulk updates from our database. And to execute this method every 30 seconds, what I'm going to do, here I will add one annotation, that is scheduled, and here I will provide. So now let's suppose that I want to execute this method after every 30 seconds. So for that I need to use fixed. So it will come, if you see it here, fixed rate, and here I need to provide the value. So it is expecting in milliseconds. So after 30 seconds, so first I will write 30, and then I need to multiply this value by 1000 to convert this into the milliseconds. So I can add 3 more 0. So that's it. This is how it will get execute after every 30 seconds. Before that, let me add one more annotation, that is enable scheduling, so that it can enable the scheduling in this class. And then what we can do it here, we can add logs as well. So I will write sysout statement, and here I will write started or executing, let's say executing aggregate like method, so that we know that this method is getting executed. And now let's say if we are updating, in that case let me write it here, sysout, let me format sysout, and here what we are going to do, we are calling DAO to update the like count for, let's say, post ID that we are using here. We will pass post ID so that we know for which post we are updating the count. And in the end, what we can do, we can add one more sysout statement as well. So here let me add sysout again, and here I will say completed, or rather than completed, ended aggregate like method. So that's it. This is how we know that okay, this method is getting executed. So everything is completed. So first let me show you the data as well in database. So it is currently 0 like. So now if I start my server, so let me save all the file first, and let me check, cross verify if everything and all the annotation we have added or not. So I think it is good. We can start this server. So let me start this server, and this server will start on 8080 port by default, because I haven't mentioned that on which port I want to start my application. So if I go to the console, so once the server got started, it will mention that it is started on 8080 server, and after that we will hit this URL, or you can say the API of the like count multiple times, and then we will see that it is not updating the record in the database. What it will do, after 30 seconds it will execute the update operation. So you can see it here, the logs are coming. Let me maximize this. Okay, so I am getting few error. Let me check. Okay, it is giving me the Redis error. So let me terminate this first. So my Redis server is not yet started, so first let me start the Redis server. So I will write Redis server, so that my Redis server will get started. So it is started now. You can see it here, ready to accept the connection. Let me start or go to the Redis CLI as well. So let me show you, currently there are no keys. So if I write keys, so you can see currently there is nothing in my Redis server. So let me clear this, and again I will start my application. So hopefully this time it will get started, and you can see the logs are coming. It is starting on 8080 port, and the application got started as well. And you can see it here, ended, because immediately it called the scheduler as well. After 30 seconds again it will get called. So what we can do it now, so let me go to the Yark. So let me go to the Yark here. So first let me write http localhost, so it will run on 8080 port, and here we going to pass posts slash, and it will be 1, that is the ID, and then I will need to mention like. I think this is the API. Let me cross verify. Yeah, this is like. Now let me go to the database first. So you can see it here, currently there is 0 count. So now let's hit this API multiple times. So you can see it here, we are getting okay 405. Okay, I have to change this to post. So let me hit it again, because we are mentioned post as the method type, so we are getting 405 because get is not allowed here. So let me do one more thing. Let me clear this console as well, console URLs, and let me hit this again. So if I hit, now we are getting 200. If I hit it multiple times, you can see if I go to the database, currently it is 0. If I go to my keys, so you can see it here, we have one key. So let me get that key value as well. So I will write post : like : 1. So you can see it is nil. I guess my method, that is the scheduler, already got executed. You can see it here, it is saying executing the like aggregate method. It is calling the DAO. If I go to my database again, Now currently we saw it is 0. Now let's see it is updated or not. So it is updated to 13. So this is how we have done the bulk updates in a single shot, as you can see it here. So what we can do, let's see. Okay, it got executed again. What I can do, I can again hit this URL multiple times. So if I see now what value is present, so it is 15. Currently it is 13, as you can see. Now ideally it should be 28 after 30 seconds. So let's wait, or let's go to the console. Once this method get executed, we will find that it is showing 28 in the database. So this is how Instagram, Facebook, LinkedIn, or you can say YouTube handle these bulk updates. So you can see method got executed. If I go to the database again, if I execute the query, now it is 28. So this is how they have handled the bulk updates. Rather than doing the updates in the synchronized manner, or rather than doing updates in the asynchronous manner as well, what they will do, they will collect all the likes in the one place, and then they will do the update in the single shot. Even if you're using asynchronous updates in your application, asynchronous thread, still it will run in some thread, or that transaction will execute in some thread. Still you should have those number of threads so that it can get executed. And you know, if in our database as well, we have to define how many connection a single virtual machine can handle. So let's say for your database it is handling, let's suppose 1000 connection. So which means only 1000 transaction you can do. If 1001 transaction is coming, it has to wait until any one of the transaction get completed. So what problem it will create, that it will increase the load on the database, as well as it will increase the response time as well, because updating the like count, as a user I am not interested about. I have updated, I have given my like, okay, this is coming. What is the latest data that is present in the database? It can come later as well, because it is not going to impact my experience. If you observe Instagram or even YouTube, you can see they will refresh the like after several interval of time. So every 10 seconds or 30 seconds you can see they will update the views. If you see any trending video on the Instagram, or even if you see any post on the LinkedIn as well, or Instagram as well, they will update the counts frequently in a sequential manner, rather than giving you the latest data whenever you are loading that post or video. So this is how these systems will work. So if we talk about benefits, what we are getting it here, one is that super fast response to the user, because we are not doing the updates synchronously, because it can make our database slow, and we are efficiently using our database as well. And what other benefit we are getting is that we have handled the viral spikes very gracefully, because these posts we don't know that RCB won the IPL, when it can come, or any video, trending video, how, when, at what particular time it can come. So we have to design our system so gracefully so that it can handle those spikes as well. What will happen if we don't do these things in the system? In that case, every time if we are doing the database write synchronously, what it will do, it can create the lock in the database as well, because you are updating the same records multiple times, so locks can pile up. Second, response time will also shoot up, because in that case, if your database transaction is not getting completed in a less amount of time, your response time will get increased. In that case, it will impact the user experience as well. And third thing is that it can possibly we have to apply the downtime during the high traffic hours as well, because if your database crash, in that case you cannot do anything. So these are the problems that we have overcome from this challenge. Now let me tell you one more thing, is that this approach is not the perfect approach. Why? Because here we are dependent on the Redis. Let's say our Redis server get crashed. In that case, what will happen? We will lose the counts that is present in the Redis server, unless and until we have created the backups, or we have added the write ahead logs so that we can recover those data. But still, if Redis crash, we cannot do anything for that particular amount of time. So what will be the robust approach so that we can apply in our production? We can use Kafka here. How Kafka can help us is that for every like that we are doing in the system, it will act as an event in the Kafka, and that can be consumed by our application for any scheduled time, that we can mention that how at what amount of time we need to poll that event, or we can poll that message, and then we can aggregate the count, and then we can update the data in the database very effectively. So next time if you like a viral post, think about what is happening behind the scene. A smart system like this allow Instagram, Facebook, YouTube to scale seamlessly even when RCB wins the IPL. If you like this video, hit the like button, subscribe to Dev Portal for more such real-world system design tutorials. The changes which I have implemented today I will push into the GitHub, so you can check that repository as well. Link I will give you in the description box as well as in the comment section. And comment me below that should we build this system using Kafka next time, or you want to see another video like this, that how YouTube handle the view updates in their system. Subscribe to Dev Portal for more such tutorials like this, and I will see you in my next video.